What is the real color of the sun? Today, we're diving into an intriguing and thought-provoking question. What is the real color of the sun? On the surface, it might seem like a simple query. After all, most of us picture the sun as yellow, orange, or red depending on the time of day. But is that what it truly looks like? The answer might surprise you, and by the end of this exploration, you'll not only know the sun's actual color but also understand how light interacts with our world and beyond. So, buckle up, because we're about to embark on a journey across science, space, and perception. What we think the sun looks like. Let's start with what we usually observe. For centuries, people have gazed at the sun, noticing its various shades. During midday, it's a bright yellow orb, and during sunrise or sunset, it paints the sky in fiery hues of orange and red. But is the sun itself changing color? Or is there something happening between us and the sun that alters how we see it? The nature of sunlight. To understand the sun's true color, we need to dig deeper into the science of light. The sun emits light across the entire electromagnetic spectrum. This includes visible light, the colors we can see, as well as invisible wavelengths like ultraviolet, UV, and infrared. Now, here's the fascinating part. When all the colors of visible light combine, they form white light. That's right. The sun's light, in its purest form, is actually white. If you've ever seen a prism split light into a rainbow, you've witnessed this phenomenon. Each color in the rainbow represents a specific wavelength of light, and the sun produces all of them in nearly equal amounts. It's this balanced mix that gives sunlight its characteristic white hue. Why the sun looks yellow from Earth? So, if the sun emits white light, why does it appear yellow to us? The answer lies in the journey sunlight takes to reach our eyes. Earth's atmosphere plays a crucial role in this transformation. As sunlight travels through the atmosphere, it interacts with air molecules, dust, and other particles. This interaction scatters certain wavelengths of light more than others. Blue light, which has a shorter wavelength, is scattered more effectively than yellow or red light. This scattering makes the sky appear blue during the day. However, because some of the blue light is scattered away from the direct path to our eyes, the sun itself appears slightly yellowish. What about sunrises and sunsets? The story gets even more interesting during sunrise and sunset. At these times, sunlight travels through a thicker layer of the atmosphere to reach us. This extended journey scatters even more blue and green light, leaving behind predominantly red and orange wavelengths. This is why the sun appears redder when it's near the horizon. Think of it like a filter. The atmosphere removes certain colors from the sun's light, leaving us with a palette that changes based on the time of day and our position on Earth. The sun from space. Its true color now. Let's imagine observing the sun from space. Without Earth's atmosphere to scatter light, we'd see the sun as it truly is, a brilliant white sphere. Astronauts aboard the International Space Station or images captured by space telescopes confirm this. The absence of atmospheric interference reveals the sun's genuine color, which is a balanced mix of all visible wavelengths. The science of star colors. The sun isn't the only star with an intriguing color story. In fact, a star's color is a direct indicator of its temperature. Cooler stars, with surface temperatures around 3000 Kelvin, appear red. Hotter stars, exceeding 10,000 Kelvin, shine blue. The sun, with a surface temperature of approximately 5500 Kelvin, sits comfortably in the middle of the spectrum. This classification makes it a G-type main sequence star, often referred to as a yellow dwarf, despite its true color being white. The historical perspective. Throughout history, the sun's perceived color has influenced art, literature, and science. Ancient cultures often depicted the sun as golden, associating it with warmth, life, and divinity. This perception was deeply tied to its appearance during the day, as seen through the lens of Earth's atmosphere. However, with the advent of modern science and tools like spectrometers, we've been able to uncover the sun's true nature, challenging age-old beliefs and enhancing our understanding of the universe. Fun facts about the sun and light. 1. Sunlight and vitamin D. Did you know that sunlight is essential for producing vitamin D in our bodies? This crucial nutrient helps maintain healthy bones and supports our immune system. 2. Solar flares. The sun occasionally releases massive bursts of energy called solar flares. These events can impact communication systems on Earth and create stunning auroras. 3. The speed of light. Light from the sun takes about 8 minutes and 20 seconds to reach Earth. That's how far the sun is from us, approximately 93 million miles. How the sun connects to daily life. Even though we might not think about it often, the sun's light affects every aspect of our lives. From the growth of plants to the energy we use in solar panels, the sun is a constant source of energy and inspiration. And understanding its color helps us appreciate its complexity even more. The takeaway: so, what is the real color of the sun? The answer is white. The colors we see on Earth, yellow, orange, or red, are simply a result of our atmosphere scattering light in unique ways. The sun itself, shining in the vastness of space, is a glowing white ball, a perfect example of nature's balance. Conclusion: I hope this deep dive into the sun's colors has enlightened you and sparked your curiosity. The next time you gaze at the sun or watch a breathtaking sunset, remember the fascinating science behind those beautiful hues. If you enjoyed this video, don't forget to like and subscribe for more explorations of the wonders of our universe.